Hi friends, this is Shravya. I'm explaining about serial communication. Serial communication is popular means of transmitting data between a computer and a peripheral device. This is used for programmable instrument or even other computer. Serial communication uses a transmitter to send data and to receive the data via one bit at a time. You can use this method when data transfer rates are low or you must transfer data over long distances. Serial communication is most popular because most computers have one or more serial ports, so no extra hardware is needed other than a cable to a computer. Um, this is RS-232 instrument and this is RS-232 cable and this is personal computer. This is via serial port. You must specify four parameters when you are using serial communication. One is baud rate of the transmission. Next is number of data bits that encode a character, and the other is sense of the optional parity bit, and the other is number of stop bits. The baud rate is a measure of how fast data moves between instruments that use serial communication. Data bits are transmitted upside down and backwards, which means that inverted logic is used and the order of transmission is from the last significant bit to the most significant bit. Flow control is optional. Hardware or software handshaking parameters for communicating with a device. To interrupt the data bits in a character frame, you must read from one right to left and read one for a negative voltage and zero for a positive voltage. A typical serial communication. This total frame is called a character frame, and this is called start bit, and this is called data bit, and this is called parity bit. The start bit is called bit time. The parity bit, if present, also follows inverted logic. This bit is included as a means of error checking. You specify ahead of time for a parity of the transmission to be even or odd. If you choose for parity to be added, the parity bit is set in such a way so the number of ones add up to make an odd number among the data bits and the parity bit. This is RS-232 RS-232 pin layout. One will display about the data carrier detect, 2 for receive data, 3 for transmit data, 4 for data terminal ready, 5 for signal ground. 6 is for data set ready, 7 is for request to send, 8 is to clear send, 9 ring indicator. This is called protective ground. This is 9-pin data type pin assignment, same as the pin diagram. The serial instrument may include some hardware devices, drivers or software dependencies for communication and should include documentation on the baud rate, packet size, stop bits and parity bits that the instrument will use. Below it, if you should see all the serial and parallel ports on your computer. In this example, the computer has two serial ports, CMOS 1 and CMOS 3 and one per parallel port. Uh, Before I have said that about the example, this is called serial and parallel. In that, these CMOS 1 and CMOS 3 are inputs and LPT is for output. This figure shows the directory path to the serial port and the configuration window when CMOS 1 is selected. From this configuration window, you can change the Visa resource name for easier identification, and you can also open Visa test panel to send and receive communication from your serial instrument. Visa test panel confirms that you have a connection. Uh, if you click on CMOS 1, then Visa will select CMOS 1 and then you can give input and input for the process. Click on the port settings tab and confirm that the baud rate, pack size, stop bits and parity bits are complement with the instrument being used in your application. If these are not set correctly, communication with the instrument will not be successful. Uh, this is the port set. If you click on this, then you can set for baud rate, data bits, parity, stop and everything. If you give details of this, then port settings will be done. This is all about serial communication. Thank you.